And so once again, let me welcome you to the 17th AMATYC webinar, which is New Pathways for Developmental Math, a look into mathematical literacy for college students. It's a webinar presented by the Developmental Math Committee. And this webinar is sponsored by AMATYC, which is the American Mathematical Association of Two-Year Colleges, and you can find more information about us on our website, amatyc.org. Views expressed by presenters are not necessarily the views of AMATYC, and if commercial products are mentioned by the presenters, they are not necessarily endorsed by AMATYC. The webinar platform is provided by the Lift Institute at Muskegon Community College, and if you have suggestions for future webinars or programs, please feel free to contact me. My email address is at the bottom of the slide there, maria.anderson@muskegoncc.edu. So at this point, I'm going to switch over to Kathy's slides. Give me a second here to find them.
And Maria, can
stop my webcam. Yep, I can hear you just fine.
Excellent. All right, well, let's get this party started. Hi, everybody. I'm Kathy Almy. I'm from Rock Valley College. I'm going to talk to you about what this new course called MLCs is today. One thing that'll be helpful, if you can scroll up in the chat window, I posted a link to the handout. Maria already sent it out to everyone, I think via email, but in case you didn't get it, if you scroll up, there's a link to a Google Doc that should be open that anybody can, or Maria just put it there, awesome, that you can see the handout. I'm going to reference it occasionally, so if you have it in front of you, that'd be great. If not, it's going to continue to be available after the webinar. I'm also going to put the slides up on my blog right afterwards, as well as the handout. And then Maria she records everything, and that will be available soon if you want the actual on the sound and everything with the webinar. So the main thing is don't feel like you have to write every single thing down. All right, so let's talk about this new course, MLCs. All right. Clicking here. Okay, here we go. So we're going to look forward first thing. All right, so I need to know a little bit about you before we do that. Which of these classes do you teach? I see. Oh, good. We're all in the land of developmental. Okay, so interesting. All right, so we have a fair chunk at the college level, but we're all doing wonderful developmental math. All right, so what I'm going to show you is graphic from statistics. Let's get to that. Okay, so I want you to look at this graphic, and even if you can't see every tiny detail on it, that's okay. This is actually a graphic that we show the students in the MLCs class, and we do some things with it. But let's imagine you were showing this to your statistics or liberal arts math students. I want to know, what would you want them to be able to do with this? So I think we have a way that you can do free response.
They can just chat in the chat window. So if they'll just respond with their ideas as they have them, that'd be great.
Yes, okay. So I'm starting to see some good words, especially if we know Bloom's taxonomy. We want to be able to make comparisons. People want to be able to interpret. This is interesting. Okay, keep them coming. One of the I'd like them to be able to see, okay, make decisions. That's good. To me, it's more than can they create these, but can they read them, interpret them, connect them, the information. It's being presented in multiple ways, and I want them to be able to make sense of them. Maria, you just said what I was going to say. I like them to be able to look at the slopes as well and see if there's a rate of change, and that Facebook has grown much faster than Twitter has, and of course we love MySpace. Basically, what is MySpace? So we have down here, we've got MySpace. It peaked in 2007, and now I don't know who's on it, but I'm sure there are people still. But the main thing is we're looking for more than just creation of these types of graphs, being able to use them, interpret them, and understand the pros and cons of what each type of graph provides us. So we're looking for more than some of the skills that we always teach in developmental math. We're looking a little deeper. So these are the things that, especially as I saw that there's several of you that are teaching college level math. I do teach on both sides of the spectrum. I teach our entire curriculum. One of the courses I teach often is statistics, as well as liberal arts math or general education math, quantitative literacy it's sometimes called. But these are the things that I want my students to be able to do, and these are things I've talked to other teachers that we want them to be able to do in their classes. And a big one is not being intimidated by problems with words. If you take a stats class, the whole book is words, and we need students to not be scared of that. So the big thing about all of these that they have in common is we're looking for connections, that they can apply concepts, and more importantly, they can retain concepts. And that's a huge problem. I think we all see that in developmental math. It's like the information is just literally washed away from them as soon as test day is over, which is very frustrating. We need them to remember it. Okay, so these things should look familiar to you, especially since we all teach developmental math. And I don't want anyone to think I think these are not valuable. I do think they're valuable. I think students absolutely need to be able to do all of these things and many more skills. But is this enough to get them there? I would argue it's not. I think we need it, and I think we need some things in addition to that. However, let's look at some things that we often do with our students before they go to a statistics or a liberal arts math class. And my question is, do these really help? I'm not saying, again, that any of these are not worth studying. They all are. The question is, do all of our developmental students need them for all the courses that they're headed to? I would argue that they don't need all of them. Of course, my personal favorite is the trains problem. I always like to mention that one. And again, they're great problems, but I think that we can do more, especially if we have some specific goals in mind for students. If they're headed towards college algebra and pre-calculus, they've got to know their algebra inside and out, especially if they're heading to calculus. That's all. Anybody teaches calculus, that's always the complaint, that students can't do algebra. So again, these skills are important, but the question is, who are they most important for? All right, so I would like your opinion. What is the purpose of developmental math? Is it to address the gaps from high school? Is it to prepare students for college level coursework? Or is it both? Okay, interesting. And many attendees think it is both. I actually thought about putting this on there, but then it was getting a little involved with all the options. I kind of think it depends. I do think we need to address gaps in high school, but I think that's predominantly what we work on right now in developmental math. I think we tend to look back. What did they not get? And if they are going on to pre-calculus, that is important. We do need to make sure there aren't gaps in their algebraic knowledge. But if we are looking at some other courses, say liberal arts math, or our non-STEM courses, meaning not for the science, technology, and engineering and math majors, I think we need to look forward, and we don't do a lot of that. We don't really look at what those courses need. We instead spend a lot of time filling algebraic skill gaps. All right, so let's talk about how we can solve some problems. I don't think we're going to solve the problem of developmental math here today, but we're going to try to get some solutions that are going to get us on our way, hopefully. All right, so these are some issues that are definitely we're all facing. We have this long developmental sequence and people don't pass it. And the big thing that's come out of the last couple of years are the idea of these very skill-heavy initiatives where we put students all in a computer lab, we put them on some kind of software, we find out what they know, what they don't know, and we work intensively on skills, again, trying to fill those gaps. Sometimes this is called the Emporium model. And it's very, very popular. And actually, I'm kind of curious, maybe we can just do an impromptu thing here. If your school is doing an Emporium model, could you put in the chat, yes? Just kind of curious.
Actually, they can use the check or the X. It's a little easier that way.
Excellent, even better.
Drop-down menu, just to check if you are using the Emporium model, and an X if you're not using the Emporium model.
So a self-paced redesign. Okay.
And again, that can be found right next to the guy with his hand raised in the drop-down menu.
Okay, interesting. So we do have some people that are in that boat. So that is definitely a common redesign attempt, and I don't think it's a bad one per se. I just think that it really suits a specific goal. If you are headed towards a lot of algebra, and if you don't have a ton of skill gaps, it can be a terrific way. I don't think it's sufficient for necessarily everything that we're doing in some of the courses where there's more, we need to make more connections and applications. A lot of times in the Emporium model, students will see math as just a stack of skills that they have to move through, and they see them as often very disconnected, and they're not always making the connections. Not to say that they can't, but in the common implementation of that redesign, they don't often see the connections made between them. Locally in our school, we've had a very successful traditional redesign, and we're very happy with it. Our students get through beginning and intermediate algebra. Definitely the impetus for us to try this new course was not, oh, students just can't get through intermediate. We have 70% of our students get through intermediate algebra. The question is, should they? That's what we were looking at. When they come to my statistics class, supposedly from intermediate algebra, they can add rational expressions. Well, they can on paper, meaning that that's what the prerequisite says, but if you ask them, most of them can't add rational expressions the day after the test on it. So it's like, okay, supposedly they can do these things, but they can't read the way I need them to, or make graphs, or when we need to set up a scatter plot, determine the increment, or what's going to be the independent variable or the dependent variable. They haven't learned those things, and they don't always adapt very quickly to them because there's so many things in stats that they have to absorb. That's just one of them, plus all the theory and the content that goes with it. So one of our concerns was that our curriculum was one size fits all. And if you think about college level curriculum, it isn't. Students take courses based on their goals. They also usually have options. A lot of times we do have faster and slower options based on how they learn. Like your school might offer a college algebra course and a trig course, and then maybe like a combined college algebra trig. So students have some options. Developmental math, we've done a lot in this country as far as speeding up and slowing it down, but we haven't done much in the way of changing the content. Okay, so here are some possible solutions that we can have to get all students ready for where they're going, and maybe in some possibly some faster and maybe even some more affordable ways. One thing we can look at is updating our content. Our content really has not changed that much, although our world is changing and the workforce is changing and employers' needs are changing, but we haven't really done a lot to address those gaps. In fact, there was just a report that came out about community colleges, I think yesterday, and it says we've got a lot of work to do, which is frustrating because we're all doing a lot of work as it is. I believe we need to balance instruction. I have a problem with going from, everyone's saying that the lecture model is terrible to putting all students in a computer lab where they're watching lectures. Technology is amazing, and I think we need technology. I think that is one of the key things we need to do to integrate developmental math, but I think we need to balance its use. I think people matter, and that's not just job preservation. I think we matter, and I think most of us, we teach developmental math. I think we would say that our presence in the classroom does make a difference. So I think we need both the human element and technology to make this work. I think we need to look beyond tests. Tests are great. We definitely need them. We're not going to get away from them, but they're not the only thing. And they don't always reveal accurately what students know or don't know. We need some other assessments that are richer and go a little bit deeper to find out students' understanding. And I believe that we need to differentiate where the courses students take based on where they're headed. Personally, I don't believe that intermediate algebra is a necessity to every single student. If we want a high bar that says you're college ready, you can have a high bar and it doesn't have to be intermediate algebra. We're going to talk more about that because I know that's a requirement a lot of people have, including my state, because that is a major issue. If we want to make change, how do we get around that requirement? Because it's a big one. Okay, so let's talk about this course, MLCs, Mathematical Literacy for College Students. The idea is you take a student who placed into beginning algebra, or let's say they passed pre-algebra, and we're trying to give them mathematical maturity. It's not an objective list, it's not a skill set, it's a goal of maturity that they can, the next course that they can be successful in is a liberal arts math, a statistics, or in our case at our school, they can go into a traditional intermediate algebra. We have a lot of intermediate algebra in our version of MLCs, but it's done in a different way than the traditional procedural way. The goal is that the student is not only ready for college level math, but college, that they can deal with the expectations, the speed, the rigor, all of it, and be able to do the mathematics that comes along with it. Okay, so let's look a little bit of a timeline. Some of you may be familiar with some of these things. If not, you'll get a little bit of a history of where this came from. In 2009, right about this time, 3 years ago, Jack Rotman was one of the key forces in, well, it's been his initiative. The New Life has been his initiative through AMATYC, and he continues to lead that. And we got together a group of faculty members from across the country, and we met in Seattle. And we talked about if we could change developmental math and we could do something different, what would it look like? Not just speed up or slow down or chunk courses differently, but if we could change it, really change it, what would that look like? MLCs, although it was not called that at first, was born out of this. The next year, this group, we applied to I believe, Carnegie, Gates, Hewlett, Lumina for funds and to start what became the StatWay and QuantWay programs. Originally it was called MathWay, and now it's called QuantWay. And MLCs is definitely integrated into that. But the Carnegie Foundation funds those initiatives. This past year, the StatWay pilots began in the fall, and our pilot of MLCs at our school also began. We're in our second semester. The QuantWay pilots for Carnegie began in January of this year, and I'm excited to share that the project is scaling, and by next year we will have many more schools that are piloting new pathways courses. Some of them are doing MLCs or other pathways, but this idea of alternative courses is really starting to take off across the country, and many schools and states are planning pilots. So first off, what I want to know is, which of these are you familiar with? And if it's none, just say so, but list any or all that you know, that you've heard of or know something about. Excellent. All right, terrific. Okay, we have a very informed group. Okay, so let's head on. And
what in here? What's the difference between MLCs and QuantWay?
Oh my gosh, what an excellent question. That's the next thing we're going to talk about.
Well then.
So glad you asked. All right, so let's get a little background to make sure that we know when I say these different words, we all are talking about the same thing. And I apologize for, there's a little, oh, what happened to, oh, it didn't come up. Okay, well, we're supposed to have a graphic, but it didn't appear. All right, so I'll just go back to
the error.
There it was. Well, it's all right. I can go ahead and talk to him. All right, so that's all right. I won't bombard you with text then. That's even better. MLCs is one semester. That's the one we're going to spend the most time talking about today. But an overview is it's one semester at the developmental level, and we're looking forward to try to get students ready for a couple of different non-STEM options and possibly intermediate algebra. StatWay is a one-year sequence, and it's integrated. And the idea is you do statistics over 1 year, and there's just-in-time developmental math inserted throughout the year as needed. When the year is over, the student will have completed their statistics requirement. QuantWay is one semester at the developmental level, and it has the feel of a quantitative literacy course. It also has the goal of being able to go into quantitative literacy or statistics, but it definitely has a more of a quant lit feel to it. It also has a just-in-time component as skills are needed at the developmental level. Those are addressed when they come up. StatPath is a one-semester developmental option that's being piloted in California, and it's also around the country, but it's really taking hold in California. I apologize, my phone is ringing. So StatPath, the idea is it basically feels like a descriptive statistics course in one semester, and it was really intended to get students ready for statistics. Okay, so you're supposed to have a lovely little graphic, but it didn't come up, so we'll just have to imagine. I'm not saying that MLCs is better than these, they're just different. They're all different, their goals are different. So one of them is the philosophy is different. MLCs very much operates at the developmental level, whereas the other three, QuantWay, StatWay, and StatPath, the level is more, we're gonna let students take, actually work with some college level content, and we're gonna do any just-in-time math as we need to. To me, it's kind of like, we're going to stay at the college level and look back at any developmental math and get it along the way, but you're more sitting at college level content. The difference too is there's not as much algebra in StatPath, StatWay, and QuantWay. Now that's a personal preference. Some schools don't want any algebra, but a lot of us, that is one of the things I would like to have my students to have more options after this course, so I'm trying to embed algebra in it. And that leads to the goals. MLCs has a broad goal, and it wants to hit a broad range of students. The student that places into beginning algebra, DM is developmental level, and CL is college level. I apologize.
And just in time?
Just in time would mean, let's say you're working on a topic and you need to graph a line, and that's part of it. You would quickly review how to graph a line, quickly review slope. My main concern with that, especially since I'm teaching this course, is for some students it's review and a lot it isn't. And so that is one of the main differences. MLCs operates if the student is at the developmental level. We're going to look to where they're going to go. We're going to try to give them lots of options for when they get there. And we're going to build algebra with us as we go, but in a different way. So that's what we'll talk about. Okay, so here are our content areas. If you have the packet, I'm not going to go through a lot of detail with that, but in the packet that I provided are all the course objectives in our school's version of it. There's more description of it. There's a link to my blog that's on there, and also I should probably type that in the window so you have that if you need it. There's implementation ideas, flow charts. There's a variety of information, but specifically there's all the objectives if you want to see that. Okay, so we have those 4 content areas. The other thing that we really address is this student is not ready for college level math or college often. So we're going to work on student and mathematical success, but we're going to do it in ways that we don't normally do that. So it's more than just what's your schedule this week and what do you need, you know, how are you going to spend your time this week? I'm sure many of you won't be surprised by this. A lot of students, they can't figure their grades. They don't understand GPA. They don't understand how college works, sometimes what's called college knowledge. What we try to do in the lessons that we've written is we embed student success, but there's always mathematics that comes with it. So it doesn't always look like student success at first, but it is. And it's kind of interesting. We also work on mathematical success because all of us that teach math, we don't have a math gene. There are specific habits and behaviors that we have, one of them being perseverance, that we want to work on with students so that they can understand and be more successful in mathematics. It's not a secret club. There are some things they can do to improve. Okay, so let's look at, I'm going to go get the pointer so you can see this. Okay, now this is, I'm going to give you a comparison in a traditional approach and the approach taken in MLCs. And one thing I want you to keep in mind, I'm not saying the traditional approach is bad. It's just different, that's all. This approach is something I use in many of my courses and it works just fine. But in this course, we take a different one. So the traditional approach is you usually have like a real numbers chapter, and then you have several algebra chapters, and then you learn what f of x is. And then you probably do way more on rational expressions and equations than much on proportionality. And you might get cross, multiply, and divide, solving some proportions along the way. But the concept is, usually in the traditional approach, we start with a skill. We say, today, this is what we're going to work on. We develop a skill. We do a myriad of examples, many, many, many examples so students can recognize what things look like. We work on problem recognition. And then we get to the applications if we have time, or if you're like me, I often run out of time. And we typically go through complete depth through one topic and then go on to the next. And if you notice, the algebra bar is very wide because that is usually in our developmental courses, that's the emphasis is on algebra. Okay, in the MLCs approach, it's different. It's a layered and integrated approach. The idea is there's 4 areas, numeracy, algebraic reasoning, proportional reasoning, and functions, and they have equal weight in the course. And what we do is we hit all 4 of them in each unit, and we go deeper and deeper and deeper as the units progress. And it's not just, can we do algebra? It's, when should we do algebra? Why? How? And not just, you know, in real life, we know equations don't come to you on a silver platter and say solve. It's, is this a situation that algebra would make it easier to solve? Okay, so how are we going to use algebra to do that? And understanding how numbers work, and being able to work with rates and proportionality, which are everywhere in daily life, and not just, and we're not talking about necessarily f of x, but two-way relationships and how they work and being able to understand that and use it. Throughout the course, geometry pops up, statistics does as well, and student success and mathematical success. And when I say geometry, I do not mean SAS and proofs, not that type of geometry. We're talking about shapes and similarity and measurement, and that just naturally appears in a lot of the problems that we're dealing with. Okay, and we're going to get more examples here in a second. These are the goals that we're working towards, and these are also Carnegie's goals for Quantway and Statway. We want students to be engaged, making connections, persisting. We're going to let them work and struggle, and if it's not productive, we're going to intervene, but we've got to let them try. We can't make everything an exercise. We've got to let some things be a problem and let them work through it. And the practice is different. The homework is different. It's very deliberate and specific, and there's a different approach to designing that. We'll talk more in a sec. I keep saying that, but I swear we'll get there. All right, so let's talk about the big elephant in the room. Let's talk factoring. So let me get rid of this arrow out of the way. Okay, if you asked me, are we going to do factoring, I would say yes and no. The reality is this, there is only so much time. And we're trying to get this student ready for liberal arts math or statistics and possibly future algebra. We cannot do everything we always did and then add on tons of problem solving. There just isn't time to do that. So we have to make tough choices. We definitely show students in our course how to factor with the GCF. because it's an incredibly useful skill, especially if you're working with formulas from business or science or any place else. It's really useful. But we could not come up with a reason to factor trinomials other than just it's an exercise for the mind, and that's fine, but we've got lots of things that we can exercise students' mind with in the class, and trinomials isn't that only way that we can get there. It really felt like we can just throw it in for the heck of it, but it isn't satisfying a need, so we didn't. People at first, they look at this and they go, oh, you're just trying to dumb down standards. You're just trying to make it easy for students to get through. I can say unequivocally that is not the case, and my students would definitely defend me in that comment. They are working, to say the least, and it is not easy. And I think we have 1A in each class, to give you an idea. It's hard, it's tough. It's a very rigorous course, and here's why. The bar is high. The next course is college level. If we pass them through and they're not really prepared for it, what has that gained? They're just going to get there and fail. So we don't want artificial success. We want something legitimate, which means it has to be rigorous. And absolutely not, we're not trying to push them away from STEM. I'm fortunate to work with my colleague Heather that I've been piloting this course with. Her background is science and chemistry and physics specifically. And we integrate science all throughout the course, and you'll see some examples in a little bit, but that's one thing that we want them to think about, and we actually talk about STEM fields in the course. We are hoping that they will consider those, and we actively encourage them and show them neat things about them. Okay, so let's talk about how you build this course, because you do build it differently than you build an algebra course. So first thing is using research. That matters. We looked at countries that were successful, such as Singapore. How do they structure their courses and their math curriculum? Read a lot of research on the brain and how students learn, specifically developmental students. And we used lessons from our redesign, which has been successful. There's been a lot of things that we learned about that. Specifically, how do you make a course work for an adjunct? One of the things we're going to do differently is recognize the fact that this student has algebra. We did an interesting thing, and I encourage you to do this. Go to your class today or tomorrow, and if you teach developmental, and ask them, how many years of algebra have you had? Our students had anywhere from 3 to 6 years of algebra. They have seen X. They do not know how to use X, but they have seen it. Therefore, when you do anything that looks traditional, they zone out, and they say, they think they know it all. Well, they don't know it all, or they wouldn't be sitting in the room. But they get complacent and often cocky. They're like, I know this. So we want algebra in this course, but we do it in clever and unique ways. The other thing we do is, it's not just, can we solve this equation? Many of them can solve equations in their sleep. The question is, should we? When should we? Why? What does algebra do for us? What is the advantages that algebra bring? Because there are many. Algebra is a beautiful subject and has a lot of wonderful things about it, and we want students to see that. We do incorporate technology. We use an online homework system for the skill part of the homework. We use paper for the conceptual part of the homework. And then the other approach that we have in the class is we kind of take the approach that people do in real life in terms of technology. We use what makes sense. So if that's their head, yes, we do mental math whenever possible. I just said yesterday we were doing problems, and I'm like, put your calculator down. We're going to do this without it because we don't need it. We use a pencil when it makes sense. We pick up a calculator when it makes sense, and I don't care if it's scientific or graphing. It doesn't matter. We use whatever they have, and we use it. And we use Excel often, and they really like that. And I'll show you in a second a project they did with Excel. I just saw Jessica's comment. I agree that not all of them are, and we definitely do develop equation solving in this course, and we develop it differently, more conceptually and concretely to begin with. Every algebra topic that we do it slightly different than you'd see in a traditional book, because even though they might have seen it, we want to make sure they get it and they understand it. I'm not saying we succeed with all of them, but most of them do. The instructional design is different. Usually we start a lesson, well, not usually, always. We always start a lesson with some kind of exploration. We give them a problem that is accessible enough they can get started on, but not so hard that they shut down and be like, I can't do anything with this. But what we want to do is, like the other day, we gave them a problem where we had them do a conversion, and they ended up with a number on their calculator, and they're like, Mrs. Almy, I got this 1.96 E10. What is that? And that was perfect. I was like, oh, that's exactly what I wanted you to say. And that led into, and we were going to talk about scientific notation, because we need that. And that's how it often appears in science classes. It's just, boom, there's a really large number, and my calculator can't show the digits. So what does that mean, and how do I work with it? Then we discover anything we need to. We do a mini lesson, we do activities, There's definitely direct instruction. We get the theory we need to, the definitions, the skills, and then we connect them. We connect them to where we started, and we connect in the exploration. We also connect them to things we've already been doing in the course. At the end of every lesson, we reflect. All of our lessons are set in a context, and students really love some of these contexts, and they get really into them. But the goal is not that they just are, worried about some specific context. At the end of the day, we want them to get the mathematics. So we always at the end reflect, what did we learn and what was the point of all of this, and how does it fit into the bigger scheme of this course and what we're trying to learn? And then we practice. And as I mentioned, we use an online homework system for the skill component, and we use paper conceptual homework for the concepts and problems. And we took a lesson from Singapore. Instead of having 150 problems and you do, say, the odds or the, every other odd or something, we have fewer problems and they do them all because they're not exercises, they're problems. Each one takes time and is unique, and they don't need as many of them to really get some challenge and depth in these topics. Okay, balance was something we learned the hard way through the pilot. We want to incorporate all these neat elements, hands-on and context and using technology and try to get more engagement in the classroom. But the question is, how much of these do you use? And we had to learn how to balance that. And one of the things that our tenet in this course is an accessible challenge, trying to do enough that keeps students interested, but not so much that they get frustrated. We also need some structure in the course. Students will get anxious if it's different every single day, but if there's too much structure, it gets monotonous. So trying to keep a balance throughout everything we're doing. And I feel like now, especially in the second semester, we've hit our stride and we have learned how to have that back and forth of these different ideas, like say group work versus whole class, that work. So the students aren't all teaching each other and I'm not standing in front of the board the whole time. We have a nice mix. So here's some pictures from our classroom. This nice lady right here is my colleague, Heather, and she looks really happy to have her picture taken. She's even happier when I video. And if you'd like to see video from our classroom, it is on my blog. I'm going to try to put up more, but there's already some that are up there. So this is from the fall class. We have a very large classroom, and the class size in this case was only 24, so you can see some desks. You can see in this, there's small groups. She's walking around, they're working, and then she has whole class time as well. We definitely have a back and forth between those two. Okay, so what is a key to making this course work? Well, we have to address the fact that we are living in a reality that has issues with that we're all facing. I'm sure you all have adjuncts, and if you're like in my case, the bulk of your developmental is taught by adjuncts, and these are lovely people, but they have often several jobs, and they are not always connected to our departments as closely as we would like them to be. So one of the things that we were very, very meticulous about when we started working on this course is we knew we had to have materials that supported what we were doing. So we are writing. And if you are curious about that and you want to see them, you can email me and I will get you a sample unit. They are being published. The fact is it's a lot of work to do this, and we want that to not be one more hurdle for faculty. We want them to have something that can support what they want to do if they're interested. And if not, some people are writing their own as well. But those materials have to work for more than just Heather and myself. We wanted them to work for any adjunct. We want to be able to give it to them and they go, and with some instruction and guidance, because in our developmental program, we do a lot of professional development. We train every new adjunct and we mentor them until they're comfortable, or we intervene as necessary. But a key component to making our redesign work is the materials, having good materials that support them. And articulation. Not every state can you just invent a developmental course and go. Definitely, in our case, we could not. I just saw Min's question, and I will get to, or Min Ku's question, I'll get that in just a second. In Illinois, we are a strict intermediate algebra state, and actually, yes, that's what I want to know. Are you as well? So, does your state require that students take intermediate algebra before they take any college level course, such as liberal arts, math, or stats? Oh, that's interesting. Several of you do not have that requirement. I want to move to your state.
To be completely honest, I don't actually know whether we have a requirement. Maybe Jack knows.
I'm not sure if Michigan does or not.
Perhaps I don't know. Should have been an option.
It should have been. Oh, that's fantastic. That's kind of interesting. Well, some of you will not have that hurdle in case you're interested in piloting this course. Oh, and I see Joyce says they require college algebra 4 stats. We have a couple different kinds of stats in our state, and some require college algebra and some require intermediate algebra. The stats I'm talking about is this one is like an elementary statistics that only requires intermediate algebra. Our state is hardline on intermediate algebra, and actually we are more hardline than most states because we require them to take geometry too. So they have to have both of those courses before they take any first level college level course. So geometry before statistics. I don't know that that necessarily makes sense, but that's what we do in the great state of Illinois. So I started working on articulation 2 years ago. I went to the people, like there's AMATYC. Well, in Illinois, it's called IMAC, or you may have, NEMATIC or MICHMATIC, whatever you have. I went to our leaders and I said, can I get a pilot? Can we try this? I don't want my students to be penalized if they take statistics. I don't want them to be penalized upon transfer. This if someone looks at their prerequisite. And the state granted us that, and they want us to have data, and they want us to get some information, and we're heading towards a vote next year on alternative pathways, and it's looking optimistic because we've been able to prove rigor. That's been a key thing. So to go back to answer a question that I saw, how many credit hours do you have? We have a giant class. Ours is a 6-credit course. Many people that are developing this course across the country are doing 4 credits. So don't take that as it has to be 6 credits. It does not. It's however many credits you need to satisfy the local or state requirements that you have. The beauty is, because we have so many requirements, pretty much anybody, the requirements they need, we probably have it on our list. So we've probably included it in some way in our course. Not necessarily, but often. And it's, how did 6 credits count? No, it's 6 credits of developmental. It's 1 semester, 6-credit course. Like I said, that's just specific to our state. You don't have to have that. Okay, so I get this question a lot. What do students think? I'm going to be honest with you. At first, they don't like it, and I'm sure you're not surprised by that. I'm not standing in front of the board saying, here's what we're going to do, and you write it down, and you mimic, and then or not mimic, but model what I do. And then do 30 of them and test on 20. Students know that inside and out, and they don't always think it's exciting, but they know it. And they like it because it is known. That's not how this course rolls. It's a completely different feel. So at first, they're like, this is different. And I've had people say, I want to go take a beginning algebra class because it would be easier. But about 2 weeks in, they buy in, or they give up. I don't know, one of the two. But they definitely go with it. And now it's funny because now they're registering for classes and they really like this. They've grown accustomed to this, and this is what they want more courses to be like. Yeah, I saw Maria's comment. No, they're not crazy about reading and writing at first, not at all. But they get used to it because one of the things we do is we try to bring in interesting context whenever possible. Not every context is going to appeal to every person. There's no way to do that, but we work hard to do that whenever possible. But they do buy in and they do enjoy it. And as I'm having them say to me right now, they're like, oh, I wish I'd had this before I had chemistry. I wish I'd had this. I wish more people had to take this. And then we had science teachers who said we should have every student take this because it's really good if they're going to go into science as well. Okay, so let's look at some examples. And Dwayne said, okay, oh, great, Dwayne's doing quant way, awesome, and find the students that find the course to be difficult. Exactly. We're not aiming, our goal is not necessarily get them all through. I mean, I would love if we had 80% pass rates on this course, but I'm interested in having a good, strong bar that will serve them well based on where they end up going. And that does mean that there's rigor involved, and that's okay. So, our course is 1 semester, although that some people could make it into a 2-semester course. Okay, so let's look at this example. This is just a page from a lesson that we have. What's interesting about this, I want you to see, and I'll try to point to some of this, anything in red, by my arrow, anything in red is an instructor note, and students don't get those. One of the things that we do, because we're thinking about like our adjuncts, is we have icons. This is group, this is whole class, this is individual. And for the teacher, they get an estimate of how much time they need. And then we also create how much time does a lesson take, and then for each lesson, and if you put them all together, how much time does the whole unit take. But we want students and instructors to have guidance. If you don't need it, then ignore that. That's okay. This lesson, we thought, Heather and I were like, oh, this will be so easy for them. We're going to look at nutrition labels. Well, they don't look at their food, first off, so that's really interesting. It ended up harder than we thought. But what's neat is we asked them, okay, where do these numbers come from? And what's interesting is none of the computations are hard. To get those numbers, you have, you know, a numerator and denominator, and you divide it. But what's on the top and what's on the bottom is where the question is. Which of all of these numbers do you need to get certain percentages? And then the other thing we want to do, and over here you can see the different areas that we hit. This is strong on numeracy, understanding numbers, units. And I'll show you some proportionality here. One of the things that we did was we had them zoom in and look at the guidelines from the government. We said, okay, so this is a 2,000 calorie diet and this is a 2,500 calorie. Let's say you have a 3,000 calorie diet or a 1,500 calorie diet. And people are interested in that, and a nutritionist may want this, or someone else that they need to know for their diet. What is the government's guidelines for you in terms of fat and saturated fat and cholesterol and whatnot? And what's interesting is fat is proportional to calories, and so is saturated fat. And so you can use that idea and you can scale it up or scale it down. You don't have to set up a proportion and cross multiply and divide. You can teach students how to scale fractions up and down and figure out how much they need. But what's interesting is cholesterol and sodium, if you look at them, they are constant. They are not proportional to, they stay the same. The government basically says we want you to have max 300 milligrams of cholesterol and we don't care how many calories you're eating to get it. Then down at the bottom it says calories per gram. So there's 9 calories per gram of fat. Most students cannot read that bottom line and interpret what I just said. So you know, we have to explain that to them. And that's a rate. And trying to make sense of that is a challenge because they don't always see everything as a rate, but there are many quantities that are. Okay, I wanted to show you an example from an open-ended project that we had students do. This was, when is it worth it to buy, like say, a Nook or a Kindle? And if you look over here to the side, these equations the students wrote, and they had to go find these numbers and pick their devices. And we didn't make this into an exercise. We gave them a paragraph, we gave them a description, and we said go. We prompt them a little bit throughout the unit because we keep coming back to this. This problem frames our unit, but we do not handhold them in this. But it's rich. You have slope in here and algebraic ideas and linear equations and functions and what goes on the x-axis and what goes on the y. And where do you get these numbers from? Because, okay, so how much does a Nook book cost? Well, you can't average all the books that are on Barnes & Noble's website. So are you going to pick the most common price you see? That's mode. Are you going to pick a sample and do an average? Well, how are you going to get that sample? Those questions are deep and they're challenging, as real life always is. So it's rich. And then what I was pointing at with the arrow was that's where the Nook and the hardcover, you have the same cost. We have students see it on the graph. We also have them see it in the table. This is where the Nook starts being cheaper, is at 7 books than if you just buy brand new hardcovers, this specific Nook. And then we also had them solve it algebraically. We had them solve equations, and they see, oh, you get that rounds to 7 books again. So the point of that is we want them to see things numerically, algebraically, and graphically and connect them and realize that each representation offers things that the other may not. And together, they give you a very rich view of what's actually going on. Because I'm getting low on time, I'm going to click through a couple of these quickly because I want to show you something else. But we do integrate geometry. In this problem, it was we want to see if each one of these was supposed to be filled with a teaspoon. And let's say you went over the same height amount in each cup, which one do you have the greater error? And then we quantified it and we measured it. And then we said, what if you did that throughout the day? Because there's actually, we had saw a news story where parents are overdosing their children because they're not measuring liquid medicine correctly. That immediately interested students because it's real. But what was interesting is when you go to quantify it, if you are over with the small short cup throughout the day, and if you do that for a couple of days, you can actually very much overdose a child. Oh, my graphic did not show. Okay, I had the formula for, the error formula for a confidence, if you're doing a confidence interval and you're, I had one of the error formulas up. One of the things we want students to be able to do is work with formulas is not only just be able to plug in numbers and use their calculator, but understand if a denominator goes up, what happens to, the formula was E equals Z sigma over root N. If N goes up, what happens to the error? If the sample size goes down, what happens? We want them to understand the idea of variation and what quantities are affecting what. Okay, and this was the lesson that's included in your packet. This is only a page of it. It's there's a lot more included. The main thing is we are not trying to teach statistics in this course. We're trying to lay a foundation for statistics in it. So And I don't have a whole lot of time to talk about this one. I encourage you to look through it. Students loved it, and it was also student success, because what we talked about was, these different degrees. What are their median weekly earnings? And that was interesting to students. What does an associate's degree get you? What does a master's degree or a bachelor's degree get you? But what's really interesting, and this was fun, this is from the Bureau of, the Census Bureau. Oh, there's my arrow. There's a line drawn on this graph, and it says average at the bottom, and I can't even read it myself. I think it says 782 or 792. But we asked students to average those numbers that were on the bars, the green bars, and we said, okay, so is that the average of them, that number that they have listed underneath? And they said no. And we said, okay, why not? And they said, because they figured it wrong. And we explained to them that we doubted that the Census Bureau had listed that incorrectly, that perhaps there was another explanation. And this tied into, we had just done weighted means. And we had a student figure out, oh, there's a lot more people that have high school diplomas, which that's the bars at the bottom, high school, some college, and associate's diplomas, those kind of things at the bottom. There's more people, and they weights those categories more heavily than people that have doctorate degrees or master's degrees. So we got quite a bit of statistics ideas in this course, and if you look in the packet, you can see what a homework assignment looks like. You can see we use my math lab for the skill component. They have to read. We make them read articles, and we help them do that because their reading is often very weak. Many of them are in a developmental reading course. So we always give them a reading assignment and help them through that. And this article is particularly short. Some of them are longer. They vary. But we try to pick things that students would find interesting. Like we have this great article from the people who work for Facebook explaining how they have to work in groups and they have to be accountable to each other. And it's a great article early on in the course. So they found that interesting. Okay, so what's the point of this course? We want to have options. So we're hoping that our students can go into quant lit or stats, but also so they're better prepared if they go into nursing or science. We specifically talked to the chemistry and bio teachers and said, what do you wish they could do? And we incorporated those. And here's some examples from that. When we do dimensional analysis, we don't do it once. We learn it, we use it when it makes sense, and we do it often. We balance chemical equations. I just had a student yesterday saying to me, that's so valuable. I wish I'd had this before I had my chemistry course. Because what's cool about that is it has a great connection to polynomials and terms and all of our notation. It's a great analogy. But also you can learn how to solve chemical equations, which is a great numerical concept. We do order of magnitude, which, from what I can see, is not in most math curriculum, developmental or college level. But in science, they always expect students to understand the concept of large and small quantities and how they relate to each other. We know that the student is not necessarily decided. So one of the things that we're very particular about is that when they get done with this course, if they change their mind, they do not have to go back to beginning algebra. We don't want them to have to start all the way over. And some pathways, they may have to do that. We didn't want that to be the case. In the famous words of Yoda, let's talk about implementation. Couple things. Students like to mimic, and they get irritated when you don't let them. So that is a struggle at first. It gets better over time. They have to be taught how to study. We don't leave every day with do 30 problems and that's it. They have readings, they have projects, they have a lot they're working on. It's deeper than that, but we're trying to get them ready for college level expectations. But what we found is if they'll put the time in, they can succeed. And that's good. That's a tangible goal to students. The other thing we found is online homework systems are awesome, but because you can do something at 100% an online system does not mean you necessarily know it. And we've seen that time and time and time again in our course. That's why I struggle with having redesigns that are completely based on just showing mastery in an online system. I want a student to be able to communicate mathematics with me, not just be able to pass a test on or a quiz on an online system. Okay, so here are some implementation options for you. Some people are replacing beginning algebra with MLCs. We're not, first off, because that would irritate too many people, because there's a lot of people that like beginning algebra in our school. But secondly, it's not beginning algebra. It is a different course. So we are doing it slightly differently. I'll show you ours in a second. Some people are using these lessons as a once weekly problem solving session if they have an Emporium redesign. So the students work on the online system in the lab, and then once a week they come together and they put these ideas together and try to go deeper with them and make connections. This is how we're using it, where we make a 2-track sequence. So if you can take MLCs and then go straight into liberal arts, math, or stats. We're using intermediate algebra as our bridge, which is a Band-Aid and not a true solution. I really want to have a true bridge course that has the same feel of MLCS, but gets any needed procedural intermediate algebra skills so they can go into, like, say, pre-calculus. This is our flow chart, and it's also on my blog if you want to be able to click it and blow it up and see it larger. The main thing is we have options. We've got slow and steady, we've got accelerated STEM and accelerated non-STEM. And when you have that, it keeps faculty and students happy because there's literally something for everybody. Okay, and this is the new thing I'm seeing. We have high schools near us that are contacting us wanting to know, can we develop this as a fourth-year high school class for that student who doesn't want to take stats their fourth year? But we need to keep their math mind working so they don't place into developmental. So this is very appealing to high schools, especially because if you look at materials, they completely embody the Common Core, and that's what high schools are trying to aim for. I believe I actually got through it. All right, so I agree, Ellen. All right, my math lab is not just, that's not the solution to everything. I think it's a great tool, but I think there's more to solving developmental math than that. Specifically, what questions do you have? What more can I answer?
Well, let me have the participants go ahead and type any questions they have in the chat window, and I'm going to just jump back to the evaluation really quick so we don't run out of time. So let me do that.
One thing while people are talking, one of the things I'm working on a lot with people across the country, not just in my state, is building this course. So I have done workshops trying to help people get their pilots started or train faculty or whatever. If you're interested in something like that, please contact me. Again, same with materials, if you want to see anything. I think Maria posted my email, and it's, yeah, I think she already posted that. But you just have to contact me, and we understand that this is brand new, and there are a lot of questions when you get started. So if you have questions, I am happy to help.
So,
how much algebra do you cover at MLCS? Dwayne's question. We have nearly all the algebra of beginning algebra. We don't have all the factoring, but we have a fair chunk of it. And we don't do, well, we're not doing rational expressions. We do rational function modeling. We do quadratic function modeling. We see systems. We don't actually graph and shade and graph linear equations and shade them. I will say that we didn't do that. Thank you, Kylina.
I've put the link for evaluation in the webinar window, and if you need to have email confirmation of your participation in this webinar, we need you to fill that out so that we can have that happen automatically. It just takes about a minute. It's very short, but it's very helpful to us. And then I thought I would also point out that we have recordings of all the past AMATYC webinars at this website. You can also get to it from the amatyc.org page. And we have a Facebook page if you want to hear about announcements about future webinars. And I'll just put it back on this here. Kathy can keep answering questions.
Is it okay for me to
Yep.
answer a few questions? Okay, so MLCS is, I worked on the initial group with Jack Rotman and Julie Phelps and several faculty that built the instructional outline and objectives for QuantWay. It is related to it, but basically if you're under QuantWay, you're funded by Carnegie, and it is a little bit more quantitative literacy with just-in-time algebra. MLCS is more for schools that are doing it on their own, and I would say I think there's more algebra in what we're doing, which is I'm not saying good or bad, I'm just saying that I do think there's more algebra in it. Yes, they struggle with critical thinking, they struggle with reading comprehension. That is something we work a lot on because they do have a tough time with that. You think a certain type of student is more attracted to MLCS? We have a lot of students that are attracted to MLCS, especially the student that struggled in traditional algebra, or the student that's like, I know how to solve it, but I can't do it your way. That student loves this class because their intuition is, I think, more valued because it's not, you have to solve it this specific way. But in general, students really like this because it is more engaging. I would say that's one of the key things. We're still doing a lot of algebra, but we don't do it in the same way. So it does appeal to students. How do you evaluate? Okay, so we have, I give a quiz at the beginning of almost every class to make sure they actually did their paper homework. They have online quizzes in my math lab and online homework to make sure that they're getting the skill component. We have a test, but the test is more than half word problems. The word problems do not look like trains or mixtures or coins or any of that. They're problems, and they're related to problems that we've been working on. But it also has skill problems and true false and concept type things. Anybody wants to see a test, if you email me, I'll email you a copy of one of our tests so you can see it. And we do have a project every unit. It's an open-ended problem, which students like. They've never done that before. Most of them have not done a problem with no one's unique solution, but instead just the best solution. They have to write. We give them a rubric, and we make them present a solution. So they work on it literally 3-4 weeks and then turn that in. Do you use a specific test for the My Math Lab part? No, we're working with Pearson, and we're building a My Math Lab course that will support our book that we're writing. Where do you find the in-class problem? Do you mean, Jessica, well, we're writing the lessons ourselves and all the homework assignments. So we're building a book from scratch. It's going to be officially in print next year, and it's available for class tests this upcoming year. Agreed, Michael. Yes, and those are the things that we're hitting. We work heavily on promotional reasoning, dimensional analysis, scientific notation, and working really hard. And I understand that you're fighting with people, and we're in the same boat. Basically, what we did in our department was we said, could we pilot this course, leave all the other courses alone, just let us try this? And people were like, cool, do what you want, because you're not messing with our beginning intermediate algebra. What's interesting, though, is students are getting wind of this, and they want this, and so we need to scale it up, and that was where we're headed now. We're adding more sections for fall and next spring, because students want this. They're like, one and done. One semester and you're done. Everything is, to them, seems relevant and contextual and applied, and they like that. So it's an attractive option to students, to say the least.
Well, I think we probably better wrap up, especially because I have to go to another meeting. But you guys all know how to get a hold of Kathy. Her contact information is on the handout.